Hey, so this is part 2 of our lesson 7.3, so I'm just going to fast forward. So far we've talked about the property to simplify our expressions. We did an example, and we did 4 more examples. Okay, so come on now to this property here, where when we're multiplying, we can also reduce and simplify. So this kind of goes back to information we've already learned before, but here's how I do it. I get really organized, but I don't actually multiply anything. So I've got this huge multiplication problem where we're finding a product, and I'm just going to put the 8 next to the 7, and then in the order of the alphabet, I'm going to put everything from the numerator. So go ahead and pause me if you need to. Then I put the 2 next to the 4, and in the order of the alphabet, I put everything in the denominator, like so. Now, I am going to go ahead and simplify. So grab your color. I'm going to say that 2 goes into 8 4 times, and that 4 goes into 4 once. So we're done. So I know in the numerator I have a 7. I'm going to say that x to the third and x to the fourth make x to the 7. I know y times y cubed makes y to the fourth. See, I feel like I'm running out of colors here. I know y squared and y is y cubed. And there's x. Yay, we have a rainbow of math in front of us. Okay, so now we get to reduce the numerator to the denominator. So let's go over what we've done. First, we just wrote everything next to each other in the numerator and the denominator. Then we reduced or simplified out the constants, the numbers, the coefficients, and then we have simplified the variables. Now that we have done that, we are going to actually finish this off. So I have an x to the 7th on top of an x, which means I have 7 x's in the numerator. I have 1 x in the denominator. They're going to cancel each other, and that's going to leave 6 x's in the numerator. Now, same story here for the y's. I have 4 y's in the numerator. I only have 3 y's in the denominator. They cancel, and I get 1 y left over. There's an invisible 1 down here, so I don't even write it anymore. And I'm done. Okay, moving on. Find the product again. This time, it's a little bit different, isn't it? Because the first thing we have to do is factor. That's right, factoring is your favorite friend these days. So I'll do the numerator right here in blue. I can see that there's a 3 and an x in common, leaving behind a 1 minus x. In green here. Now I'm going to write them all on the same line because I know I can since it's a product. A 4 and a 5 would make me a 1, so I'm thinking it's a 4 and a 5 because 5 times 4 is 20, 4 times 5 is 20. And if I want a positive 1 there, that means I have to have a positive 5 and a negative 4. Okay, let's check it. X times x obviously makes x squared. Positive 5 times negative 4, obviously, negative 20. So what we care about is that inside the OI part. So that would be a 5x and a negative 4x. Yes, it works. Okay, you have your dividing line. And now I'm going to factor here. The nice thing about 5 is prime. So it has to be a 5 and a 1. And it has to be a negative 5 here, but a positive 4. So that means the 5 is positive. Okay, let's check it. X times x, obviously. 5 times 1, obviously, that's why we have that part. Now, 5x plus negative x, yep, it works. Okay, and then this is just 3x. So let's review what we've done. We drew one big dividing line. Because it's a product, we know that basically it's all on top and it's all on bottom. We didn't actually multiply anything. We did factor, and now we get to grab another color and cancel stuff. So 5 plus x cancels with 5 plus x. 3x cancels with 3x. And we have a problem. Our problem is right here. They look like they're the same, but are they the same? So think of 1 minus x. It's equal to negative x plus 1. Negative x plus 1 is not what's down here in the denominator. But what if I factor a negative out? That would leave x minus 1. That is what's in the denominator, isn't it? Okay, so I'm going to rewrite this problem real quick just to make it a little organized. It was negative times the quantity of x minus 1 with the x minus 4. And in the denominator, I have x minus 1. Okay, I am in fact allowed to cancel these now, which means the denominator completely goes away. And my final answer is negative times the quantity of x minus 4. Okay, here's another find the product. Alright, before I even start this problem, I'm going to draw an invisible one. I'm going to make it visible. There you go. Okay, now we have to factor, factor, factor. Alright, so I just realized we didn't practice this kind of factoring. So let's pause it and find the formula. Okay, there it is. So it's been all the way since chapter 4 since we've talked about this, or for some of you it's been all the way since algebra 1, if it was even in there. But this is a difference of cubes or a sum of cubes, depending on what it is. In our case, it's a difference. So I have x cubed minus 27, and I know that 27 is really 3 cubed. So the numerator is just x plus 2. The denominator is this difference of cubes, which is going to be x. Let's see if I can get my mouse back. There it is. Now I have to erase. That's what happens when I press pause. Okay, give me black, make it skinny. There you go. It's going to be x minus 3. How do I know it's a minus? Well, because it's a minus 27. Then it says a squared. Well, a was x, so I'm going to write x squared. Now, the formula says if it was a plus, you write a minus, but if it was a minus, you write a plus. So you do the opposite. AB is just the 3 times the x, and b squared is plus 9. Okay, now that is the denominator. So I have x plus 2 over here. I have the quantity of x minus 3 times the quantity of x squared plus 3x plus 9. I can already see it's going to cancel, but I'm going to just write it again for you so that you can really see what happens. It's over 1, those cancel, and I get x plus 2 over, whoops, that's a minus, x minus 3. X plus 2 over x minus 3. Okie dokie. Alright, so here's some more practice problems for us. I'm just going to start working them through. Let's see, this is 3 times 6 times x to the 5th times x times y squared times y squared. Now if you can do it in your head at the same time, go ahead. You know I can, but I also know that you guys like it when I show work. So this 3 cancels that 9, leaving a 3. That 3 cancels that 6, leaving a 2. That 2 cancels that 8, leaving a 4. So I have a 4 down here and an invisible 1 on top. I have x to the 6th on top and y to the 4th, x to the 4th in the denominator, and y squared. Okay, so let's finish that up. That's going to be x squared on top because it was 6 and 4 on the bottom, meaning 4 cancel out. The y's also cancel out, leaving y squared, and it's over 4. Now, for those of you that remember from, what was it, chapter 5 maybe, where we did, this was the exponents chapter where it was 6 minus 4, and then it was y to the 4 minus 2. I'm just basically doing that in my head, canceling them in my head. See how I get x squared, y squared after all. Okay, number 6, start by factoring. So it looks like I can take a 2 and an x out, leaving x minus 5. And then, of course, here's your x plus 3. This is going to be x minus 5 times the quantity of x plus 5. It's that special pattern that you've started to memorize. And here's 2x squared. Okay, the minus 5's cancel, the 2's cancel, and this, I'll change to blue for you, this 1x cancels, turning this x into a 1. Did you follow that? There was only one x on the top, but there were two x's on the bottom, so they cancel, leaving one of them on the bottom. Okay, so the numerator is x plus 3, and the denominator is x times x plus 5. That one's maybe a little trickier. Think about that. Okay, right here, this is a difference of cubes where the a value would be an x and the b value would be a 1. And it's that formula I wrote on the other slide. And you already know, I hope, that it's going to cancel with that. So some of you could even skip some work right now. But I will go ahead and write it out for you. That would be x minus 1 times the quantity of x squared plus x plus 1. And they're going to cancel, but I'll write them down for you anyway. There you go. And you get x plus 5 over x minus 1. Okie dokie. So now we're into division. I'm going to stop the lesson again so we can chunk it, and I'll put on another video.